Hello everyone. Welcome to this tutorial video on exploring the modeling and simulation of a system in both electrical and mechanical domain. This feature can help you to run a complete motor drive simulation, couple any electrical circuit to a mechanical one, reinject speed or torque value into control stage. Let's show this from an existing schematic of a PM-SM drive, full bridge power converter. Here, we're going to observe how to connect each part into the same schematic. The power stage is showing a 3pH inverter with ideal switch. We can observe the DC input voltage equal to 500 volts and 6 switches, drawing the legs of the power converter. Each switch is driven by green control signals. Those signals are coming from control stage, including a speed reference block of 200 RPM, a PID controller, an inverse park block, and a PVM generation. In this circuit, we use comparator block for creating the gate signals. 3. Between the power stage and the control stage, the mechanical part has been implemented with a permanent magnet, synchronous motor, a mechanical load and speed sensor blocks. The three-phase currents are directly connected to each phase A, B, and C of the PM-SM. The outputs give the angular position, in green on this schematic, and the rotation shaft. The angular position can be directly connected to a control block, whereas the rotation shaft can be directly connected to a speed sensor plus mechanical load. The mechanical load used in this example is a generical load, and only linear coefficient torque T1 is set up with a small value of 50 M. Also, the output of speed sensor provides a control signal, which can be fed directly to control part without any interference block. A gain block has been added after the speed sensor block, allowing to obtain the speed in RPM. Finally, after running the simulation, we can observe the results into the Result tab and check the output speed. The speed is well achieving 200 RPM as requested into control stage. This feature shows you how to connect different types of domain, and it is to be noted that no interface block between power and mechanical stages is required. The blocks provided into this schematic, such as speed sensor, can extract the required signal and feed it somewhere else. This concludes the tutorial video about modeling of a system in both electrical and mechanical domain.